What's up, my mathletes? That's right, Mr. Muscarella coming at you. And in this video, we are going to take a look at finding the equation of a hyperbola given certain characteristics about said hyperbola. So let's grab our notes, if you have notes, and let's get ready to go. So in this example 2 here, we're going to find an equation whose vertices are 4, 0, negative 4, 0, and have an asymptote of 2x. Then state its foci. So let's plot the information we're given, shall we? Let's take those vertices. I'm going to plot those. Negative 4, 0 is going to go right there. I'm going to put a little v by that. I'm going to put a little v by the other one. So that tells me those are vertexes, vertices. Knowing that, that tells me also my parabola is going to be one of those left-right ones. So I'm going to be going like that, and that's really cool to know. So that is exciting. So I know to start out with, I got to find the center of that. And to find the center, I'm just going to figure out halfway in between those two v's. And if I can count right and figure out the distance between these two, halfway in between there, of course, will be at the origin. That is very nice. So the origin is going to be where my center is. So I know it's left and right, and I know the coordinates of the center are 0, 0. So that means I'm going to have an x squared minus a y squared one. I just don't know the numbers that go underneath the x squared and the y squared, but more on that in a moment. Because when I know it's a left-right one, the distance between the center and the vertex is going to give me the a value. So I have to make sure that I count really carefully from the center to the vertex. And when I do that, I get 4. But remember, that's just the a value. And I want underneath, I want a squared. So I've got to write a 16 is going to go underneath the x squared. So that takes care of the very first clue that we're given there with our two vertices being 4, 0 and negative 4, 0. So that was very nice. Thank you for helping me with that part of it. Now, the other clue, the asymptote, this piece right here, the asymptote of 2x, that is going to help me come up with the b value or the b squared value, the value that goes underneath the y squared component. So I've got to plot this line. And when I do that, I go from the center. So 2x, I'm going to start at the center, go up 2 to the right one, put a dot. Up 2 to the right one, put a dot, and continue that, going all the way up to the right, and go all the way, starting at the center, then go down 2 to the left one, down 2 to the left one, down 2 to the left one. So when I know that, I'm like pretty solid. So I have this piece here, awesome sauce. So I've got that asymptote that would be have the positive slope. Now likewise, I have a negative slope that's going to have the same pattern. So I'm going to go up from the center, go up 2 to the left one, up 2 to the left one, up 2 to the left one, up 2 to the left one. So you're going to continue that pattern until the edges of the paper all the time. You're going to go both directions, whatever those asymptotes are going to be. All right, so once we've got those pieces all set, connect those dots, that is going to give us our two asymptotes. Now, with the asymptotes, what that helps me do is I'm going to then sketch my box. And once we get the box kind of sketched, we're going to figure out the b value. So I know the box, so I'm going to start at the vertex, just kind of go around and sketch the box and go all the way down to the asymptote, go over to the left. So this is going to be kind of the guidelines right here for my hyperbola. And knowing that, I can also start to sketch, I'm going to have one parabola going, or hyperbola going to the left, and the other part is going to go to the right. So those asymptotes in that box kind of serve as the guidelines for that. Now the b value. So let's figure out this b value. If I count, there's a couple ways you can do it. One is by counting. So I could simply count from the center to the top of the box. Or I can start at the vertex and count to the top right corner of the box, or the other vertex, and I can count from there down to the corner of the box. So either way, I'm counting from that one spot, the center or vertices, to a corner or a part of the box. And I got to count that distance very carefully, and if I do that, I will get a value of 8. So that's one technique. You can just count to the top of the box from the center, and I get a value of 8, which means b squared would be 64. So 64 would go on the bottom. Now there's another technique that you could use, and you could look at the asymptotic formula for this, and since we know this is one that goes left and goes right, then I could have y equals 2x is one of my slopes, and what I know is that my asymptote the number 2 is going to be equal to the formula of B over A. Now, I figured out what that A value was before, right? So we know that 2 is going to be 4, or A over 2, or A over 4. And then when I multiply, then I get 8 for the value of B. So then when I find B squared, so that's another technique you could use for those of you who really like formulas. You could do it using that technique. Either way, counting or using the formula should get you a B squared value of 18. Once we're golden with that, booyah, we've got our equation for our hyperbola. So that was the first thing we had to do. The second thing we had to do was come up with a foci. So we got to state the foci. So those coordinates we will get from the formula. So the foci are going to come from this formula. And that's, remember, C is going to have a value of the A squared plus B squared, that whole part, square rooted. This, I already have the A squared and B squared terms from before. So I'm going to have 16 plus 64. That is going to give us 80. And when you square root 80, like if I square rooted 81, so let's think about this for a second. If I had the square root of 81, we know that would be 9. So the square root of 80, even though we'll simplify this to get 4 square roots of 5. So going through that process, you simplify square root of 80, you get 4 square roots of 5. I know that that's got to be a little bit less than 9, whatever that decimal is. I can plug that in my calculator and get that, but I don't really need the exact value. All I need to know is, okay, so I'd be over here, here's one of my foci, and then from the center, I would go a little bit less than 9 over to the right, and that would be my other foci. So if I had to graph the foci, that's where they would be located. Remember, foci for the parabola as well as the hyperbola are both on the inside of the curves. So with that said, what are their coordinates? So from the center, we go left and right 4 square roots of 5. So you could say 0 plus or minus 4 square roots of 5. And then the y value, of course, would be 0. So that's one way you could do it. Now, another way is you could just scrap the 0 in front of the first part and just put plus or minus 4 square roots of 5, 0. Or you could write them individually and say, well, one's at negative 4 roots of 5, 0, and the other foci is at 4 roots of 5, 0. So you could separate them like that, or you could write them together. And the only reason you can write them together is plus or minus 4 roots of 5, because this one's not a gross one. Or because this one is, I don't want to say gross one, but this one has a radical in it. So if you had an integer value for C, then you'd actually have to list what that coordinate would be. So you'll see that in other examples. But that's how you do this one. So we have found the equation, and we have the coordinates for our foci. So we are done with this one. That's it for this video. Thank you guys for watching. Make it a great day, and I'll catch you a bit later. Peace out, Cub Scout.